Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion of physics, AS Physics Paper 2 questions that you can be asked from AS Cambridge. And we're going to look at physical quantities and units, and then we are going to discuss how you are supposed to answer questions from that particular topic. If you are new to Proflan YouTube channel, consider consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. We are going to begin from the first section, the possible question that you can be asked, and in this case, can see here we are told that use expression for work done in terms of force to show that the SI base unit of energy is kg meter square per second square negative second square. Now, in this case, we know that work done is given by the formula force times distance. Work done is force times the distance. So we need also to understand that force is ma, and we are going to multiply that distance. Now we have mass, we have acceleration, we have distance. Then we are going to substitute the units of each of the quantity that we have here. Mass, the unit is kilogram. Acceleration is meter per second square, and distance is meters. So we can be able to multiply meter and meter to get meter square, and then our unit now can be written as kg meter square per second square. Then now we need to move to Roman part B, and in part B we are told that the energy is stored in an electrical component is given by E equals to Q squared over 2C. Now, in this case, remember that we need to find the units, the base SI base unit of C, which is a constant in that case, but 2, which is a number, 2 is a constant which does not contribute to any unit, because 2 doesn't have any unit, so we are going to disregard it when we are considering the units that we are going to use here. So we are going to make C the subject of the formula, and in this case, Q is given and Q is IT, current times time. Let's make C the subject of the formula here, and this 2 does not contribute to the units of C, so we are going to say C is equals to, now Q squared is the same as IT squared, but at that given point you need to remember that the unit for current is ampere and the unit for time is second. So we're going to put that in bracket, and then we're gonna square that. Once we have this, we can also substitute the unit for work done, but remember work done is equal to the energy transferred. So that's why we're using the units for work done for energy, because work done is equivalent to energy transferred. So in order to simplify this, I can multiply here by s squared, here by s squared, so that I can cancel this and that, and which means that now I can be able to write the unit for C in a simplified manner over kg meter square. Now this can be written, we remove kg and meter square from the denominator, and we are going to introduce a negative because they were the denominator in that case. Next question is a question to do with random error and systematic error. When you do an experiment, there are sources of errors. You are not accurate. The measurements that you take are susceptible to uncertainties. Some errors may arise. Now we have two types of errors, which are random error and systematic error. Random errors are those errors which can be as a result of taking a reading wrongly, that can be as a result of not reading from the correct angle, some errors as a result of not recording the value correctly in the correct number of decimal places. So you find that there are some slight errors that will arise in the process of taking and recording readings. And systematic errors are errors which are as a result of a faulty measuring instrument. For instance, if there is a zero error, it's going to affect all the values in the same direction. If the instrument is calibrated wrongly, it means it's going to affect all the values in the given direction. So systematic error can be corrected by recalibrating or calibrating the measuring instrument properly, and also can be corrected by removing the zero error. But for random error, you need to take multiple values, and then maybe you can be able to compare the way the values are, and you can be able now to notice anomalous point, those values, those points which are not consistent with the rest. And maybe even you can be able to do average, and in that way you'll be able to uh, remove and remove that error. We need to move now and answer the question, because we are told that measurements of a constant current in a wire are taken using analog ammeter. Remember, analog ammeter, they have a scale where you read the currents, and for the measure, describe the possible cause of random error. Random error can be due to error of parallax, wrong reading, and wrong recording of the values, reading from the wrong angle. Those are some of the sources of random errors. And also, we can talk of error of parallax. Yes. We can also talk of a systematic error is a zero error, and also wrong calibration of the ammeter. In that way, we can be able to have a systematic error which affects all the values. Moving to question 2, length, mass, temperature are SI based quantities. Be very careful when you are told that are SI based quantities, because sometimes you'll be told to talk of SI based units, but in this case we are talking about SI based quantities. Now state two other SI based quantities. Number one, we can talk of current, and also we can talk of time. In CIE, in CIE A level physics, AS, you need to understand the 5 SI based quantities. That is length, mass, temperature, current, and time. But if we are talking of SI units, the SI unit for base SI unit for current is ampere, and for time is seconds. We are going to also look at a question to do with uncertainties, and in this question we are told that the acceleration of free fall may be determined from the oscillating pendulum using the equation G equals to 4 pi squared L T squared, where L is the length of the pendulum and T is the period of oscillation. And in the experiment, the measured values of an oscillating pendulum as shown here. We were given L equals to 1.50 meters, uncertainty of plus or minus 2%, and time period T 2.48 seconds, plus or minus uncertainty of 3%. Calculate the acceleration of G. Now, the acceleration of G, we are going to substitute the value of L and the value of T into the formula that was provided here. And that is basically what you are going to do without using those percentages. You just substitute the 1.5 and the 2.48, but you square the 2.48 because T was squared. So if you work it out, check using your calculator what you could get there. If you work it out, you're going to get 9.628, and then we can be able to round off to 9.63, because you can see most of all these values that were given here were given to correct to 2 decimal places. So there's no way you can be able to get the calculated value having a higher accuracy than uh, the measured quantities. Determine the percentage uncertainty of G. Remember, G is obtained by dividing L and T squared. So to find percentage uncertainty where quantities are divided, when we were learning this, we say that to get percentage uncertainty of a derived quantity where two quantities are divided or multiplied, you are going to add the percentage uncertainty of the individual quantities. For both division and multiplication, you are going to add the percentage uncertainties. So in that case, we are going to now say that percentage uncertainty, I'll use U for uncertainty, percentage uncertainty of G is equals to the percentage uncertainty of L, percentage uncertainty of L plus the percentage uncertainty of T. But since T was squared, I'm going to multiply the uncertainty of T by 2. So if it was cubed, we were to cube that. That is the condition. If you have the percentage uncertainty of a quantity and the quantity is raised to that power, then the percentage of maybe T squared will be the percentage uncertainty of T times 2. If it was raised to power 4, you'll multiply by 4. Then now we need to substitute the values that we were given there, and then that becomes 2 plus 3 times 2 because the percentage and uncertainty of U of T was 3 times 2 because it was raised to power 2. And then if we work it out, we're gonna get our answer as plus or minus 8%. Now, once you have the percentage uncertainty of G, then now the range of values under which this T is going to lie will be plus or minus 8%. But if you want to work out absolute uncertainty, you take the percentage uncertainty 8 over 100 times the value of G, that we had obtained, and that would be plus or minus 0.77, 0.77 plus or minus that. Moving to question number 3, and question number 3 is talking about scalar and vector quantities. At this point, under this topic, you must understand how to define a vector quantity. You need to understand how to define a scalar quantity. A scalar quantity is a quantity that can be described by both size and direction. Rather, a scalar quantity is a quantity that can be described by only size but no direction. Now, in that case, we need to say that scalar has magnitude or size but no direction. Vector quantities are quantities which can be described by both size and direction. And we can now give examples of vector quantities that can include displacement, velocity, acceleration, momentum. Those are some of the examples that we can talk about. But from a scalar quantity, we'll talk of scalar quantity, they don't have direction. So we can talk of power is a scalar quantity, temperature is a scalar quantity, momentum has direction, so it's a vector quantity. Then you need also to understand how to answer question to do with vectors, combining vectors. And there are different methods that you learned how to combine vectors. Number one method was a tip to tail method, meaning a tip of one vector is joined to the tail of the other vector so that you can be able to obtain the resultant vector. There is also how to deal with vectors by combining and drawing a parallelogram. We are going to look at that in the next session. And in this case now, we are told an aircraft is traveling in wind as shown. The velocity of the aircraft in still air and for the wind is that. So we have wind blowing at 28 meter per second, and the still air is the aircraft is moving in still air at 95 meter per second. So the velocity of the aircraft is given as 95 to the west, and the velocity of the wind is given 28 meter per second from 65 degrees south of east. Draw an arrow labeled R in the direction of the resultant force of the aircraft. Remember, since we have the wind blowing uh, towards the aircraft motion, something that you need to realize at this point is that the direction in which this aircraft is going to move is going to be affected. The aircraft is going to change its trajectory. So in order to ascertain in which direction it's going to move, we are going to draw this vector that we were having down here, and I will mark this particular point and use tail to tip method. So I have my tip there, and then this is the tail. So this vector that we are having here, I'm going to move it in such a way that its tail is joined to the tip of the direction of the aircraft. So I'll move it to this particular point. So you can see now we have a resultant vector running from this point to this other point. Now this is our direction in which the aircraft is going to move. So maybe from there we can now answer the question to determine the magnitude of the resultant velocity of the aircraft. Since we had 95, we have 28, and then we form a triangle, and then we can be able to apply cosine rule at this point in order to work out the resultant vector. Applying cosine rule, we are going to get our answer reducing to 110 meter per second at the speed. You can be able to use scale drawing, you can be able to use resolving vectors, and also you can be able to use geometry, and then you do the calculations in order to work out questions like this. Moving to question 4, this is a question also to do with uncertainty, to do with errors, and let's see what the question entails. One end of a wire is connected to a fixed point. A load is attached to the other end of that wire, and it hangs vertically. The diameter of the wire D um, and the force F are measured as D equals to 0.4 plus or minus 0.02 millimeters. That is absolute uncertainty. F has an absolute uncertainty of plus or minus 0.5 newtons. Now, the instrument for the measurement of the diameter, of the wire, state the name of the suitable instrument that can be used for that. Remember, we are talking of a thickness of millimeters of a thin wire. That one, we are going to use an instrument called a micrometer screw gauge. We can be able to use a micrometer screw gauge, or we can use a digital calipers. We can be able to use a digital calipers or a micrometer screw gauge. How random error could be reduced using the instrument. More measurement can be taken, and then the average is obtained so that we can be able to reduce the effect of random error, and ensure also reading correctly to avoid the error of parallax. The stress sigma in the wire is calculated using the formula 4F over pi d squared. So now we are supposed to show that the value of stress is 1.99 times 10 raised power 8. In this question, we are just substituting F and D, and also ensure that diameter D is in SI units meters. So we need to do the substitution. Force was 25, and the distance was given, the diameter was given as 0.40 millimeters. So we have to convert those millimeters to meters by dividing by 1,000 like that, and then we square our answer. Now what you need to remember, whenever you are solving this part of the question, you are not using the absolute uncertainties. You are using the measurement that was given. Then absolute uncertainty will be used in the next part, whereby we are working out the percentage uncertainty G. Now, since for you to obtain not percentage uncertainty of G, but we are finding uncertainty, percentage uncertainty of stress. Now, since stress is obtained by dividing force and D squared, 4 and pi are the constants. They don't contribute to uncertainties of the quantity calculated. So 4 and pi are not going to be involved when we are finding the uncertainty of stress. So the first thing that we're going to do is that since f and d squared are divided, then we know for you to work out uncertainty, percentage uncertainty of stress, we need the percentage uncertainty of f and we need the percentage uncertainty of d. Then use the percentage uncertainty of d to get the percentage uncertainty of d squared. So first we're going to find the percentage uncertainty of d, and that's going to be equal to the absolute error or absolute uncertainty of d, which is 0.02 divided by 0.4, which was the measurement, then times 100. This gives us percentage uncertainty of d. Then we're going to work out percentage uncertainty of f, and f percentage absolute uncertainty of f was 0.5. Divide by 25 times 100 will give us the percentage uncertainty of f, and if you work it out, you are going to get your answer equivalent to 2.0%. Now, to work out the percentage uncertainty for stress, it will be the percentage uncertainty of f plus 2 times the percentage uncertainty of d, because d was squared. D was squared. Then we are going to say 2 times the percentage uncertainty of D, which is going to be equivalent to 12 as our final answer in that case. Now, once you have the percentage uncertainty, questions will be asked whereby you are supposed to write your value in terms of plus minus, determine the value of stress with absolute uncertainty. So for you to get absolute uncertainty, you'll get the percentage uncertainty of 100 times the value of that stress that we were given, or that quantity that was calculated before, and that will be equivalent to 0.24 times 10 raised to power 8. So here we can write stress. Now the answer for stress, the answer or the stress of this material is going to lie within this range, 1.99 plus or minus 0.24 10 raised to power 8, like that. If you are getting value from this video, consider subscribing so that anytime we're going to upload another tutorial, you'll be notified. Take this opportunity to subscribe, like this video, and if there's any other video that you would like me to work on, and also you can be able to leave a comment down below so that I can be able to know how do you feel after watching this video. Moving to question number 5, and question number 5 is a question that is talking about combining vectors, and when vectors are acting in opposite directions, we usually subtract those vectors, and in that case we are going to get 7, because we shall say 12 minus 5 is 7 newtons. When they are acting at right angles, so you have a vector that direction, another vector in this direction, so to get the resultant vector is a vector that is joining like that, which is the longest side, which is the hypotenuse. So we can be able to apply Pythagoras theorem at that point when vectors are perpendicular in order to get the resultant vector this case. Now, and we are told that an object X rests on a smooth horizontal surface. Two horizontal forces act on X as shown in the figure. a force of 55 Newton is applied to the right, and a force of 18 Newton is applied at an angle of 115 to the direction of the 55 force. Then we are supposed to work out the resultant vector, and in that case, or the resultant force, whereby we are supposed to use resolution of forces or scale diagram to show the magnitude of the resultant force is approximately 65 newtons. So in order to do this, I'll wish to redraw this diagram a little bit so that we can be able to use resolution of vectors at this point. I'll prefer using resolution vectors, but you can be able to use scale drawing, draw a parallelogram here, complete a parallelogram, and then the resultant vector or resultant force is going to be the diagonal in that case. Now here I want to use resolution of vectors or forces in order to work it out. So that was the original diagram that was given, and that angle was 115 degrees. So what I'll do, I will shift this angle that I have, the vector I have here, I put it somewhere down here so that I can be able to resolve it into, this is 55 Newton, the other one was 18 Newtons. And then I resolve this to vertical and the horizontal component. 18 Newtons has both horizontal and a vertical component. Since it's pulling down, it will be pulling down, giving a vertical component, downward vertical component, and this angle that we are having here is going to be what? This angle is going to be this 65, right? Because 180 minus 115 is 65, so this angle is 65. Then it means the vertical component here is 18 sine 65. The horizontal component at this point due to this force is 18 cos 65. Now, we need to understand that there are two forces which are acting in the horizontal direction and they are acting in the same direction. So we are going to add 18 cos 65 plus 55 so that we can be able to get the force that is acting in the x direction. So that is going to reduce to what? If we work it out, we are going to get 62.61. If you put it in your calculator, you are going to get 62.61 newtons acting in the x direction. Let me move this a little bit here. And then we have a force that is acting downward. It's only one force, which is 18 sine 65, which is 16.31. And now you see these two forces are now perpendicular again, but we have this force acting in that direction, 62.61, and the downward force is acting and is a value of 16.31. I've shifted that vector so that the tail of the second vector is at the tip of the first vector, which is 62.61, so that I can be able to use now Pythagoras theorem in order to work out the resultant vector at this point. So we can be able to work this out, and you applying that, we are going to get our answer approximately 65, which was 64.7, which is approximately 65. Yes, so that's what we are supposed to do in order to get the resultant vector using resolution or resolving vectors. Yeah, so let me just move this down here so that I can be able to have my working in the correct point where this work was supposed to be placed. And then we can now move to the second part, determine the angle. Determine the angle between the resultant force and the 55 Newton force, which means that we are working out angle theta, and that's going to be tan inverse of opposite of adjacent. So which means that we are going to have our angle as 14.6, approximately 15, approximately 15. We are told that the third force of 80 Newton is now applied to the x in opposite direction of the resultant force. So meaning we are going to work out the resultant force here. So we shall subtract the two forces, and then we get the resultant force is going to be 15 newtons. And for us to work our acceleration to the force over mass, and then substitute, our answer becomes around 5.6. And then moving now to projectile motion, an object, a delivery company suggests using a remote controlled aircraft to drop a parcel into the garden of a customer. When the aircraft is vertically above the point P of the ground, it releases the parcel with velocity that is horizontal of magnitude 5.4 meter per second, and the path of the parcel is as shown there. So what we need to understand that horizontal motion is constant throughout, but vertical motion is affected by gravity. And by the time the parcel was being dropped, the horizontal component of the velocity was 5.4, but the initial vertical velocity was 0 meter per second. So we are going to determine the height of the parcel, but we are told that the time it took the parcel to land on the ground was 0.81 seconds. So the height will be, we shall use the equations of motion, and we shall apply the equation of motion S equals to ut plus a half at squared. And in that case, our initial velocity in the vertical direction was 0, so we end up having S, which is our h, a half at squared. And then substituting now the quantities that we have, a half times acceleration is due to gravity, 9.81 times 0.81 squared, which means that our answer becomes 3.22 meters. So the height was 3.22 meters. To calculate the horizontal distance, which is the range, is horizontal velocity times the time it took the parcel to land on the ground. So that's going to be, range is 5.4 times 0.181 times 0.81, and then the answer becomes 4.4 meters. 4.4 meters as our final answer. And if you got value from Proflan YouTube channel in this video, consider subscribing, so that in time I'm going to upload further tutorials for Cambridge physics, Edexcel physics, math, pure math. You'll be notified. See you in the next video.